Good afternoon, students. Today we start our next lecture of manure fertilizers and soil fertility management. So the topic is integrated nutrient management. Okay, so before knowing what is soil nutrient management, what is integrated nutrient management, what is the difference between both of them? So the term integrated means collaboration, okay, in which we are using different, I can say, uh, physical, chemical, biological, all the nutrient management take place in integrative nutrient management. And one topic is also included in this, that is about fertilizer recommendation approaches and what are fertilizer, what are their classifications. So after this lecture, you have to know about what is an integrated nutrient management, what is the concept of integrated nutrient management, what are the goals for integrated nutrient management, so why it is needed nowadays, what are the advantages, what are the differences between integrated nutrient management from conventional farming, and then we have to know about what are the fertilizer recommendation approaches, and then we have to know about the fertilizer and their classifications. So all you should be learned from this lecture. Okay. So before going to further, I want to tell you about what is integrated nutrient management. It is also known as INM. Okay. So what does it mean? It is the maintenance or adjustment of, I can say, the fertilizer or the plant nutrients, so that we can obtain, our soil can obtain optimum amount of nitrogen, phosphorus, potash and other nutrients which are required for the crop plant. So nutrient is an mineral, or I can say that element which is required for our crop to grow well in the soil, and so that we have to get maximum yield from it. Okay, so the main purpose of doing this integrated nutrient management is to improve the soil, as well as also to conserve our resources, and third thing, we have to take maximum productivity by using this integrated nutrient management. Then there are some definitions of integrated nutrient management. That first is the, it is the maintenance or adjustment of the soil fertility and plant nutrient supply at the optimum level, so that we can get desired crop productivity. That should be increased, and this to be done through optimization of the benefits from the possible resources. Means if you have one resource, like water resource, okay, so sunlight resource, so you are using all these resources collectively, like for input resources, all these come under integrated nutrient management. Another definition is we have to use different sources of plant nutrients, and then they should be integrated, so as to check the depletion, and then we have to maintain our soil health, because you all know, by supplying chemical fertilizer regularly, or in I can say in overdose, we are applying fertilizer in overdose, so that's why we need a proper system for it, so that our soil health can't get disturbed due to this overutilization of these fertilizers. And another definition is, it is a practice in which all the nutrient sources, like either it is organic or inorganic or biological, we are combining them and we are applying them in our soil, so that there should be a balance. Okay, we have to make a balanced diet for our crop plants, so that our soil health or soil fertility also get improved. So integrated nutrient management, also known as INM. Okay, then I will talk about the concept of INM, that is integrated nutrient management. So as you all know that India is an agriculture based country, means it also helps in exporting and importing their products. So So agriculture play a very vast role in India, as well as because our everything is dependent on food. If we are doing, I can say, if we are doing any kind of job, we require food. So that food is coming from agriculture. Okay. Then you all know that geographical area of India is near about 3 to 9 million hectares, and it can I can say it exports near about 17% of the world population, and near about 2.5% of the land area, and 4% world freshwater resources. So India play a vast role for agriculture, and as you all know that all the seasons are preferably are present in India, all kind of seasons and all kind of crops also grown in India. So it is a vast country which have a large agriculture scale production. We are using high yielding varieties, we are using fertilizers on proper recommendations, and we are different varieties of cereals, pulses. So majorly the main crops are rice and wheat. They are grown, I can say, from last 50 to I can say 70 years ago, means mid 1960s. From that time, it is grown. Wheat and rice are grown regularly on in India. Okay. Then chemical fertilizer also enhancing the yield, because after green revolution we are getting high yielding varieties, and we also getting some fertilizers. So if I can talk about fertilizers, so they have high nutritive value. So for that, what is happening, the yield are getting increased because our soil at that time is productive, and when we supply our fertilizer it becomes more productive. But nowadays only chemicals are present in our soil, nothing else. So for that we are preferring this integrated nutrient management. Okay, and after green revolution, the use of fertilizer are quite, I can say, higher as compared to when there is before green revolution. And many of the fertilizer cause leaching, volatilization, eutrophication, greenhouse gases emission also take place. So chemical fertilizer on one side giving us the yield also, but on other side the soil fertility and productivity also get damaged due to the heavy dose of these chemical fertilizer. And fertilizer use, as per I can say, mistakenly identified, and when it is identified, so it is very harmful to our environment. And another reason for it is we can't discontinue it because we need profit. Okay, I know by supplying organic manures or by supplying biofertilizer, I don't get that much yield which I am getting from the supplying of these fertilizers. So that's why what is happening, we are can't I can say we can't discontinue the fertilizer application. Okay, and which further are harming our environment, our I can say our environment, our soil health, human health also. But we are not stopping for applying these fertilizers because we are just focusing on our production, we are focusing on our profit, because everyone need money. So that's why we are not doing that thing which is I can say which is quite good for us. We are preferring to do bad for our soil, for our environment, which further at longer time harm us also. So then I will talk about, so that's why the integrated nutrient management, this term will came into our I can say study, because it is a balanced diet. Means if I can say I will eat rice 3 times a day, okay, or I can say 365 days. So one day it can't be, I can't get any energy. So therefore that integrated nutrient management came, in which there is a balance of all there is a balance of chemical fertilizer, there is a balance of supplying the organic manure, there is a balance of applying biofertilizer, but we are applying them collectively into our field. So next is the goals of INM. So basically the goal is to optimize plant production in the form of yield and quality. See, if we are growing simple wheat crop, okay, and we are applying fertilizer about 250 kgs of urea, so what we are getting, the quality get inferior. Okay, we get the inferior quality of our product. We are getting the yield, but we don't get the quality product. It is a quantitative product at that time. So by integrating nutrient management, we are getting the proper micronutrients, proper macronutrients, and that's why the quality of these plants should be, I can say, good for us. Then we are getting profit also by doing integrating nutrient management. Then we are conserving our resources also. There is not overutilization of any resources, any input which we are applying into our main field. So, and further, by integrating nutrient management, as we are applying the biofertilizers and organic manures also into it, so the soil health or soil quality and its productivity, its fertility also get increased, or I can say improved. So, why we need INM? Why there is a need of INM? Why this term came into account? As I already told you about the overutilization of chemical fertilizers, which further increase the production, which further increase the quantity, but they at some point it is inferior the quality of the product we are eating. Okay, because there are some reasons like soil which receive these plant nutrients through chemical fertilizer, the productivity of that soil is quite, I can say, decreasing day by day in a very large amount. Then due to this decline in this productivity, the deficiency of secondary and micronutrients also affected. How they are affected? From, I can say, I am supplying in my field. This is my field. Okay. So what is going through? I am supplying 100 kg of nitrogen. Okay. It's just an example. 60 kg of P2O5 and 60 kg of K2O. That is per hectare, I can see. So what is happening? I am just applying only this primary nutrients, that only NPK. So if I can say from last 50 years I am just applying this NPK, only NPK in a high amount. That amount is also increased day by day. Okay, so what is happening? Only 3 nutrients are going into the soil. What about the rest of the micronutrients? We are not applying them, right? So what is happening? They become deficient in our soil, and which further reduces the physical health of the soil. I can say acidity develops. The total soluble salts concentration is also increasing due to the application of this due to the application of these chemical fertilizers. As we all know that we are not applying single fertilizer. For nitrogen we are applying urea. For phosphorus we are using SSP, DSP. Okay, and for potash we are using MOP. We are not supplying one single fertilizer. We are supplying all the fertilizer which further affect our soil health. Okay, so that's why this integrated nutrient came into account so as to maintain a balance. As you all know that organic manure, or I can say the biofertilizers, somehow increasing the water holding capacity of the soil, but they are also improve the soil microbial activity, because these microorganisms are feeding on organic matter. And you all know that in biofertilizers there are some our bacteria which fixes our nitrogen. So due to the application of biofertilizers there is a reduction of nitrogen into the soil. We are not applying that much nitrogen to our crop plants. Okay. So by doing integrated nutrient management, we are using chemical also, okay, biofertilizers also, organic manures also, which further results in a balanced diet If I am giving you proper one chapati, little bit of rice, one egg, so there is a balanced diet. Hope this concept is clear to you. Why we are studying this, what is the role of it, why we are preferring it. Okay. So, as you all know, conventional farming and what is the difference between the I&M and conventional farming. So, in conventional farming, what is going? We are the people are giving focusing on, I can say, only on grain yield, means the consumptive part through chemical fertilizers, or by growing high yielding varieties, or by using chemical pesticides. This is the conventional farming. Okay, but in case of integrated farming, we are combining the objective of production with ecology and environment for getting optimum crop nutrition, so that our crop get optimum nutrition. You all know, if we are applying anything in excess, if I give you 10 rotis at one time and your capacity is just to eat 3 to 4 rotis, so rest of the 6 rotis are waste. Similarly, for crop also, if we are applying a large amount of nitrogen or any other fertilizers, so they can't take that much amount. Okay, so that's why INM came, which optimizes the crop nutrition, which optimizes the soil health, how and also reduce the nutrient losses like the leaching, the volatilization processes. So that is the main difference of INM from conventional farming. Then what are the advantages of INM? First is it enhances the availability of applied as well as native soil nutrient. Means either we are applying it or the soil nutrient is present in that. INM enhances it. It fixes it, or it helps in exchanging that nutrient, which further be utilized by our crop plants. Then the synchronizes the nutrient demands with the native supply. Okay. Third is it is a balanced nutrition. Okay. It provides balanced nutrition to the crop plants, and it improves the physical, chemical, and biological health of the soil, because all these processes helps in maintaining the soil health, and we all know that soil health depends upon these physical, chemical, and biological condition of the soil. And furthermore, it also minimizes the deterioration of the soil. It I can say it also reduces the environmental pollution. Okay, then carbon sequestration, I can say to this. Then it also I can say it also reduce the ground surface water. Okay, the nutrient losses are directly going into the groundwater, which further be I can say consumed by humans or animals. That is injurious to our health. That's why we are using filters nowadays, because the groundwater is directly come from underground water, right? So where we are applying our fertilizers also, everything we are applying. So INM helps in reducing the nutrient losses. Then it is also minimize the antagonistic effects resulting from hidden deficiency and nutrient imbalance. You heard about hidden hungers. Hidden hunger is a term which is used for the plants which don't show any kind of deficiency or toxicity on themselves, but they are still deficient or toxic for that particular nutrient. That is hidden hunger. If they need it, they can't show. Okay. And if there is a deficiency, then they also can't show it on their morphological features. Okay, so by through INM, I can say this hidden hunger be reduces or minimizes. Then again I will talk about the components of the INM. So basically there are 6 components of INM. So the components are 6 in number. So first is organic manures, then green manures, then crop residue and organic waste, then synthetic fertilizers, then crop rotation, then biofertilizers. So all these are the components of the INM, in which we are using, if we are doing integrated nutrient management, we have to use these components. so that there should be a balanced diet or balanced nutrition should be available to the crop and soil health get improved. So if I talk about, we already talk about organic manures. So organic manures, I can say those manures which are which are made up from the dead and decaying part of the living plant tissues and animal. Okay, so there you all know that they are of two types, bulky and concentrated. Bulky are those which are applied in high amount, but they have no nutritive value. And the example is farmyard manure, compost, vermicompost. Then, if I talk about concentrated organic manure, so it is of two types, and it may be applied in small amount because it have high nutritive value as compared to bulky organic manures. So, the example is our oil cake, the blood meal, bone meal. Okay, then came the green manures. So the green manures are those crops which are applied in our main field, which are incorporated in our main field, and it is of two types. One is green manuring and second is green leaf manuring. In green manuring, what we have to do is we just planting our green manure crop, either dhanja, into our main field. Before the sowing of our main crop, we are sow these green manure crop, and then we sow our I can say our main crop. And after 6 to 8 weeks, we are incorporated this green manure crop into our main field, also known as green manuring in situ. And in green leaf manuring, what is going, we are just collecting the twigs and the dead tissues or dead leaves of the plants, and then we are collecting it and just incorporated in our main field. So that is green leaf manuring, in which there the example is suba bool leaf manure, sorry, neem ho gaya, and suba bool. So these are some example of green leaf manuring. Then I will talk about the crop residues and organic waste. See, nowadays we are also preferring about the direct seeding. So in direct seeding, what is going on? Suppose I have grown a wheat crop. Okay. So after harvesting, the residues are left. So without burning it, the residue remain in the soil surface. Then before sowing and after harvesting of our main wheat crop, what we are doing? We are just doing seed drilling. Okay. We are using drill machine, so that, or we are using cultivator, so that our residue should be incorporated into our soil surface. Okay, so this is the crop residue management, or I can say the organic waste which we are incorporated into our main field. Then I will talk about the synthetic fertilizers. So synthetic fertilizers are those fertilizers which are prepared in the industry. Okay, which we are prepared in the industry. The example is urea, DSP, MOP. So, what they are doing? They have high nutritive value as compared to our organic manures. So we are directly applying it them, and they are easy to, I can say, apply in our main field as compared to organic manures, because we need a large number of, I can say, transportation. We need more labor so that we can put our organic manures in our main field. So we are using synthetic fertilizer because they are easy to apply. We can apply through sprayers. We can apply through broadcasting. So there are different methods. So next, in integrated nutrient management, what we are doing, we are using the crop rotation and intercropping. With our main crop, we are just making row wise difference and grow another crop with it. Okay. So then the biofertilizers. So what are the biofertilizers? They are the inoculants. They are the microbe inoculants which are applied in our main field. Like the example is rhizobium. There are number of biofertilizers like phosphorus solubilizing bacteria is also there. There is some I can say mycoplasma, vesicular or vascular. Okay, So rhizobium is for legume crops. If there is our pulse, that is pea, and if we are mixing our pea seed with the rhizobium biofertilizer, so it can fix the nitrogen. Okay, so this is all about the components of INM. Hope these terms are already clear to you all. So the next topic, this is all about the integrated management. Then I will talk about the fertilizer recommendation approaches. So why we are studying this topic? Because we have to know what in which amount or in how much amount we are apply fertilizers. Okay, so that's why we are going to I can say further approaches. We have to study approaches like there are basically four approaches to fertilizer recommendation. Why we are recommending the fertilizers? So it is based on the soil test. Okay, which we are doing in our lab in KVKs. So for that we are the example. I'm just giving the example like how you can know that we need 120 kg, 60 kg and 60 kg of NPK in wheat? How you can know? It can be 220, it can be 260, it can be 260 again. Why we are saying we just applying only, the crop need only 120 kg or 60 kg and 60 kg of NPK in our wheat crop? So this is due to the different testings we are doing. Our soil scientists doing different soil testing analysis based on nitrogen, phosphorus and potash. Then we have to come to this result that our crop need this amount of NPK, or I can say 5 kg of zinc sulfate, because it is becoming deficient in our soil. So we are also start to give 5 kg of zinc sulfate. So that's why we are used to study fertilizer recommendation, which is based on directly on the soil testing, okay, which is conducted by our I can say soil scientists. So if I talk about the approaches, basically there are four approaches. First one is the build up and maintenance. Second one is the sufficiency. Third one is basic and saturation, and fourth one is quantitative approach. I will tell you one by one about these all approaches. So in build up approaches, what is happening? So mainly this approach comes only for maintaining the soil fertility for future years. So you all know that the main goal is to provide more nutrients to the crop plant and to maintain the nutrient level in the soil, so that our yield cannot get, I can say, fluctuated. So we have to get the optimum yield. What we are doing, we are just maintaining the nutrient level of the soil. Second, the fertilizer recommendation are made to apply enough fertilizer to both meet the nutrient requirement of the crop and build up a nutrient level in the soil. Means if your crop require 2 kg of nitrogen, and if I said in soil it requires 100 kg of nitrogen, so there should be the availability of that particular nutrient in the soil. So build up means we have to maintain both the nutrient level for the soil as well as for the crop. Second, the next point is the build up or maintenance approach. Is that approach in which the nutrient availability in the soil is increased over time for future years. And this approach, in this approach, what we are doing, we are using the fertilizer more as compared to other approaches, and there should be a, I can say, risk of nutrient deficiency because leaching process take place. Okay, and which further decrease the soil productivity and soil fertility. And there is a risk also because due to the heavy dose of these fertilizers, there is a large impact or negative impact on the environment. Okay. Then the next approach is the sufficiency approach. In sufficiency approach, what is happening? The fertilizer applied only to meet the nutrient requirement of the crop. In first approach, they are focusing both on soil and crop. But in this, what is we are focusing on only on the nutrient requirements of the crops. And the main goal of this approach is to get the maximum about the sufficiency approach. So in sufficiency approach, what is happening? The fertilizers are applied to meet only the nutrient requirements of the crop. We are not focusing on the maintaining the nutrient level of the soil. We are just focusing on how much fertilizer should be applied for which is required for our crop. And the main approach of this I can say fertilizer recommendation that it gives the maximum profitability in a given year, and which further also minimizes the fertilizer application. And due to this, there is I can say the leaching process also I can say reduced. The soil test levels are low. When we are doing the soil testing levels, in which we are calculating the nutrients analysis, we are doing the nutrient analysis. So the fertilizer rates are quite higher than the nutrient removal by the crops. Means we are applying 100 kgs and crop is taking only I can say 2 kg or 50 kg as an example. So due to this sufficiency approach, we are just knowing the levels, and by doing this approach, the soil test levels are becoming high, and we just know the recommendation of the fertilizer applied. Then next is the basic cation saturation approach. So cation means that ion which contains the positively charged. Okay, that is cation, and the main approach of this is to maintain the maximum mean, and it directly consider the recommendation for calcium, magnesium, potassium. Like in the proportion of cations, there should be 60 to 85% of calcium should be there, 6 to 12 kg magnesium should be there, and 2 to 5% potassium should be there. But this has many drawbacks, as you all know that there is a sodium cation also, there is potassium cation also. The cation capacity is more as compared to the anion capacity, because some of them exchange, some are fixed. So that's why this approach has many drawbacks, as cations are minimum in I can say in our sandy soil. Okay, so this approach I can say that is not appropriate for fertilizer recommendation. Then the quantitative approach, this focuses on the soil test value, in which we have to know the actual amount of nutrient which is present or available in the soil. It can easily be taken by the crop. So that is quantitative approach. And the main thing is that the amount of nutrient that has to be applied through fertilizers is the difference between the total nutrient by the crop and the amount of nutrient available in the soil. This thing we have to test it in quantitative approach. And this amount, it should be divided by or adjusted by dividing it with efficiency factor, that should be less than 1. Okay, in which we have to know the efficiency of fertilizer, which fertilizer can be easily be taken by the crop, in which I can say in which source. So this is the quantitative approach. Then I will talk about fertilizers. So fertilizers can be defined as the I can say those chemicals or those elements which are applying, which are made industrially, and which can have more than one essential plant nutrients. Either it have both NPK, it should be only nitrogen. But you all know that the chemical formula of nitrogen is NH2CONH2. So it contains the nitrogen concentration also, the ammonical form also, the carbon also. Okay, so another definition is a fertilizer is natural also, synthetic also. Means the natural fertilizer, it should be your manures. Okay, and the synthetic fertilizers are the chemical based fertilizers which are directly enhance the plant growth and fertility. Okay. And if I talk about what is the difference between manures and fertilizers, so if I talk about the what is the difference between manures and fertilizers, so manures are organic in nature, so fertilizers are opposite. So they are inorganic in nature. Second, manures have no definite chemical composition, but fertilizers have. Like urea contains 46% of nitrogen. So that is the definite chemical composition. So next is the manures are obtained from plants, dead and decaying material. Either they should be animals and human resources. But fertilizers are mined, or I can say manufactured. We are manufacturing them. Then manures improve the physical properties of the soil, but fertilizers don't, because many of the fertilizers are I can say leach down into the soil. Okay, then via manures we are supplying all the major minor and micronutrient. But for fertilizer there is a case is the difference. Okay, the difference is that supply we are supplying if we want to supply nitrogen, so we are supplying urea. Okay, if we want to apply I can say phosphorus, so we are applying DAP, diammonium phosphate. So that is different. But through manure we are giving all the major micro minor all the nutrients to the crop plants. Then the manure is derived from I can say French word, and fertilizer are derived from a Latin word, and manures are bulky in nature and fertilizer are non-bulky in nature. Then I will tell you about the classification of fertilizers. So basically they can be classified into three. One is straight fertilizer, second is complex fertilizer, and third is mixed fertilizer. So in straight fertilizer, what we are doing, these fertilizers are maintained, or I can say prepared or manufactured, which contain only essential one primary nutrient. Means primary nutrients, you all know that there are NPK. These all three are primary nutrients. So straight fertilizer, those fertilizer which only have one primary nutrient, like either it is nitrogen, phosphorus or potash. Then if I talk about the complex fertilizers, so these are those fertilizers which contain more than two chemicals, or I can say nutrients. Means it contains the it contains the primary nutrient like N and P also, P and K also, or NK also. Okay. So NK means nitrogen and phosphorus. I was just giving you the examples. Then mixed fertilizer are those fertilizers which are not, we are not applying in a definite proportion. We are mixing that manually. Means we are taking two fertilizers and we are just mixing them and just applied in our field. That are mixed fertilizers. And two more fertilizers are also, that is low analysis fertilizer and high analysis fertilizer. So these are those fertilizers which contain 25% of the, I can say, any primary or essential nutrient. Means for the I can give the example of phosphorus. Okay, or I can give the example of DAP. So in DAP you see that the nitrogen content in DAP is 18%, and whereas if the phosphorus content is 46%. So that is low analysis fertilizer. Okay. If I talk about the high analysis fertilizer, which contain more than 25% of the essential primary nutrients. Means, example is the urea. It contains 46% of nitrogen, so it comes under high analysis fertilizer. So these are the definition that in straight fertilizers, these are those which supply only one primary plant nutrient. Either it is NPK, कोई भी हो सकता है. Then example is urea, ammonium sulfate, potassium sulfate. Then the complex fertilizer which contain two primary nutrients. Either it is the combination like DAP. So DAP means diammonium phosphate, which contain ammonia also, means nitrogen also, and phosphorus also. And then in mixed fertilizer, we are just mixing them. We are taking two straight fertilizers, urea and DAP, and we are just mixing them thoroughly, and they can be applied in the field mechanically or manually. So, students, this is all about today lecture, and these are the references you can follow up. You can learn from these sites and these books and the hyperlinks, and there are some research papers also. You also go through them while studying this integrated information. Thank you. This is all about today's lecture.